All right, here we go. We're going to do our next iteration of learning for the Google Cloud platform. What we're going to do is go over a couple of case studies that are going to help you understand this platform a lot better. Why? Because you're going to use the cloud to solve problems. With this, you're going to go over a couple of case studies that'll show you why the cloud is important, how you would use it, and what are some potential pitfalls you might encounter and how you would solve them. So let's go with case study number one. This is a game case study. This game company makes online session-based multiplayer games for the most popular mobile platforms. The game company builds all their games with some server-side integration and has historically used cloud providers to lease physical servers. A few of their games were more popular than expected, and they had problems scaling their application servers, MySQL databases, and analytics tools. The game company's current model is to write game statistics to files and send them through an ETL tool that loads them into a centralized MySQL database for reporting. The game company is building a new game, which they expect to be very popular. They plan to deploy the game's backend on Google Compute Engine so they can capture streaming metrics, run intensive analytics, and take advantage of its autoscaling server environment and integrate with a managed NoSQL database. Typical requirements include a game backend platform. This dynamically scales up or down based on game activity, connects to a managed NoSQL database, and runs customized Linux distros. The requirements include it dynamically scales up or down based on game activity. It processes incoming data on the fly directly from the game servers and processes data that arrives late because of slow mobile networks. It allows SQL queries to access at least 10 terabytes of historical data and processes files that are regularly uploaded by users' mobile devices. And it's for use only on fully managed services. The CEO said the last game did not scale well with the previous cloud provider, and it resuming in lower user adoption and affecting the game's reputation. The investors want more key performance indicators to evaluate the speed and stability of the game, as well as the other metrics that provide deeper insight into usage patterns so we can adapt the games to target users. The current CTO says the technology stack cannot provide the scale needed. So they want to replace the MySQL and move to an environment that provides auto-scaling, low latency load balancing, and frees up from managing physical servers. The CFO says they're not capturing enough demographic data using metrics and other KPIs. As a result, they don't engage the right users. So they're not confident that marketing is targeting the right users and they're not selling enough premium blast ups inside the game, which impacts the revenue. Question 118. Game company wants to redesign their testing strategy for the new game backend. How should their test coverage differ from the previous system? Answer. Tests should scale well beyond the prior approaches. Why? Because given past issues with scalability, the testing strategy must emphasize performance and load testing that scales dynamically to match production-like traffic. It is crucial to validate the auto-scaling behavior of the Google Cloud deployment. So this requirement is to dynamically scale based on gaming activity. Question 119. The game company needs a cost-effective way to thoroughly test new versions of their backend before public release. Answer. Create a scalable environment in GCP for simulating production load. Why? Simulating production load in a scalable GCP test environment allows for realistic user testing under expected and peak user conditions. This ensures cost efficiency by using ephemeral resources only during testing. Question 120. The game company wants to implement continuous delivery with quick updates and rollbacks from many microservices. Answer. The goal should be using Google Container Registry, Kubernetes Engine, and HTTPS load balancer. Why? Because Container Registry stores container images, Kubernetes Engine orchestrates containerized services, and HTTPS load balancer handles scalable traffic distribution. Together, they enable fast rollouts, rollbacks, and multi-service updates. Question 121. The gaming company is experiencing 503 errors and slow responses during a record surge in users. The backend uses autoscaling. Answer. Verify that the project quota hasn't been exceeded. Why? 503 errors during autoscaling often indicate quota exhaustion. If resource limits are hit, GCP can't provision new instances, causing availability issues. Checking quotas should be the first diagnostic step. Question 122. The gaming company needs isolated application environments, dev, staging, prod, with access controls. Staging requires some production access. Answer. Create a project for development and test, and another for staging and production. Why? Using separate projects allows for stronger isolation between environments, while shared resources like APIs or services can be accessed through IAM and service level permissions when necessary. Question 123. A gaming company is building a real-time analytics platform for a new game. They need to process streaming data, handle late arrivals, run SQL queries, and store uploaded files. Answer: use Cloud Dataflow, Cloud Storage, Cloud PubSub, and BigQuery. Why? Cloud PubSub ingests real-time events. Cloud Dataflow processes the data stream and handles late arrivals. Cloud Storage stores uploaded files. And BigQuery supports SQL queries over large historical datasets. This setup is fully managed and meets all analytical platform requirements. Case 2. This company manufactures equipment for mining and agricultural industries. About 80% of their business is from mining and 20% from agriculture. They currently have over 500 dealers and service centers in 100 countries. Their mission is to build products that make their customers more productive. Background. The company was formed in 1946 when several small family-owned companies combined to retool after a Great War. The company cares about their employees and customers and considers them to be extended members of their family. The company is proud of their ability to innovate on their core products and find new markets as customers' needs change. For the last 20 years, trends in the industry have been largely toward increasing productivity by using larger vehicles for the human operator. There are 20 million vehicles in operation that collect 120 fields of data per second. Data is stored locally on the vehicle and can be accessed for analysis when a vehicle is serviced. The data is downloaded via maintenance port. The same maintenance port can be used to adjust seat operational parameters, allowing the vehicle to be upgraded in the field with new computing models. About 200,000 vehicles are connected to a cell network, allowing the company to collect data directly. At a rate of 120 fields of data per second, with 22 hours of operation per day, the company collects a total of about 9 terabytes per day from these connected vehicles. So, the company's existing architecture is composed of Linux-based systems that reside in a data center. These systems gzip CSV files from the field and upload via FTP, transform and aggregate them, and place the data in their data warehouse. Because this process takes time, aggregated reports are based on data that is 3 weeks old. With this, the company has been able to preemptively stock replacement parts and reduce unplanned downtime of their vehicles by 60%. However, the data is stale. Some customers are without their vehicles for up to 4 weeks while they wait for replacement parts. So the requirements are to decrease unplanned vehicle downtime to less than 1 week without increasing the cost of carrying surplus inventory. Support the dealer network with more data on how their customers use their equipment, better position new products and services, and have the ability to partner with different companies, especially with seed and fertilizer suppliers in the fast-growing agricultural business to create compelling joint offerings for their customers. So the CEO says they've been successful in capitalizing on the trend toward larger vehicles to increase the productivity of customers. The technology is changing and it's occurring rapidly, and the company's taken an advantage of connected devices to provide customers with better services like intelligent farming equipment. The technology has been able to increase farmers' yields by 25%. By using past trends to adjust how the vehicles operate, these advances have led to the rapid growth of the product line, which is expected to generate 50% of revenues by 2020. The CTO says the competitive advantage has always been in the manufacturing process with the ability to build better vehicles for lower costs than the competitors. However, new products with different approaches are constantly being developed. I'm concerned they lack the skills to undergo the next wave of transformations in the industry. Unfortunately, the CEO doesn't take the technology obsolescence seriously, considers many new companies in the industry to be niche players. The goals are to build our skills while addressing immediate market needs through incremental innovations. Question 124. The CTO wants analysts to centrally access real-time data from connected vehicles to predict potential failures. Answer: use Cloud PubSub to stream telemetry data into BigQuery. Why? Streaming data with Cloud PubSub allows for real-time ingestion of high-frequency telemetry from millions of vehicles. Storing this in BigQuery enables centralized analysis at scale. This architecture supports proactive failure prediction and aligns with Google Cloud's streaming analytics best practices. Question 125. The development team needs to build APIs that focus on delivering business value rather than managing infrastructure? Answer: Google App Engine with Google Cloud Endpoints, focusing on APIs for dealers and partners. Why? App Engine simplifies deployment without managing servers. Cloud Endpoints allow rapid development and secure API management. This setup supports business goals while minimizing development overhead. Question 126. The company wants third-party tool developers to access vehicle data securely and on behalf of dealerships. Answer: Use an OAuth-compatible access control system. OAuth 2.0 is a standard for delegated authorization. It lets third-party apps access user data without sharing credentials and is ideal for secure access to dealership-specific vehicle data. Question 127. The company is expanding to 20 million connected vehicles, each sending high-throughput telemetry. Answer: Stream data directly to Cloud PubSub. Cloud PubSub handles massive scale and low latency event ingestion, making it the best option for real-time telemetry from millions of vehicles. Question 128. To reduce parts wait time, the company needs to eliminate the 3-week data aggregation delay. Answer: Replace FTP with streaming transport, switch CSV to binary format, and apply machine learning for predictive analytics. Streaming enables real-time processing, binary formats reduce file size and latency, and machine learning enables predictive parts stocking to minimize downtime. Question 129. Which legacy processes will be most impacted by cloud adoption? Answer: Capacity planning, TCO calculations, and OpEx CapEx allocation. Cloud shifts budgeting from CapEx to OpEx. This changes how capacity is planned, on demand versus static provisioning, and requires new total cost operations models for cloud cost efficiency. Question 130. More vehicles are gaining cellular connectivity. The company wants to replace unreliable FTP transfers. Answer: Use Google APIs over HTTPS to send files to multi-regional cloud storage buckets. Multi-regional cloud buckets ensure durability and low latency across geographies, and using HTTPS with Google APIs improves reliability over traditional FTP. Question 131. The CTO wants to analyze raw telemetry stored across regional GCS buckets to diagnose breakdowns. Answer: Pre-process data in each region, then consolidate into a multi-regional bucket and analyze with Cloud Dataproc. Regional pre-processing reduces data egress costs. Multi-regional storage supports efficient global access, and Dataproc provides scalable batch analytics. Question 132. To reduce storage costs, the company wants to archive data from unconnected vehicles for future ML use. Answer: Compress data hourly on the vehicle and store it in a GCS cold line bucket. Cold line is ideal for infrequently accessed data, such as ML training sets. Hourly compression optimizes storage costs. Question 133. The company wants to improve efficiency across 20 million vehicles by automatically adjusting operational settings. Answer: Capture operational data, train ML models, and deploy them in Cloud ML to automate adjustments. ML models can optimize vehicle performance in varying conditions. Hosting in Cloud ML provides scalable, centralized decision-making across all units. Question 134. Their autonomous agricultural vehicles must be secure during operation. Answer: Use trusted platform models, TPM, for secure boot and place vehicle electronics in Faraday cages. TPMs verify system integrity at boot, and Faraday cages protect hardware from electromagnetic interference, ensuring both digital and physical security. Case study number 3. This company is a global retailer with over 10,000 stores in 16 countries. The stores carry a range of goods like groceries, tires, and jewelry. One of the company's core values is excellent customer service. In addition, they recently introduced an environmental policy to reduce their carbon output by 50% over the next 5 years. The company started as a general store in 1931 and has grown to one of the world's leading brands, known for great value and customer service. Over time, the company transferred from only physical stores to stores and an online hybrid model with 25% of sales online. Currently, the store has little presence in Asia, but considers that market key for future growth. Here's the solution. This company wants to migrate several critical applications to the cloud, but has not completed a technical review to determine their suitability for the cloud and the engineering required for migration. They currently host all the applications on infrastructure that is at the end of its life cycle and is no longer supported. The company hosts all of its applications in 4 data centers, 3 in North America and 1 in Europe. Most applications are dual-homed. The company understands the dependencies and resource usage metrics on their on-prem architecture. Application Customer Loyalty Portal, LAMP, Linux, Apache, MySQL, and PHP application served from the 2 company-owned US data centers. Database is an Oracle database that stores user profiles. It's 20 terabytes, complex table structure, well-maintained with clean data, and a strong backup strategy. A Postgres SQL database that stores user credentials. This is single-homed in US West with no redundancy, backed up every 12 hours, with 100% uptime service level agreement, and authenticates all users. The compute is 30 machines in US West Coast. Each machine has twin dual-core CPUs, 32 gigabytes of RAM, twin 250 gigabytes of HDD, RAID 1, 20 machines in the US East Coast. Each machine has single dual-core CPU, 24 gigabytes of RAM, and twin 250 gigabytes HDD RAID 1. And storage has access to shared 100 terabyte SAN in each locations, with tape backup every week. So the business requirements include optimizing for capacity during peak periods and value during off-peak periods, guarantee service availability and support, reduce on-premises footprint and associated financial and environmental impact, move to outsourcing model to avoid large upfront costs associated with infrastructure purchase, and expand services to Asia. Technical requirements include assessing the key application for cloud stability, suitability, modifying the application for the cloud, moving applications to a new infrastructure, and leverage managed services where feasible, and sunset 20% of capacity in existing data centers, and decrease latency in Asia. So the CEO says that the company will continue to develop personal relationships with the customers as more people access the web, because the future of the retail business is in the global market and the connection between online and in-store experiences. As a global company, they also have the responsibility to the environment through green initiatives and policies. The CTO says the challenge of operating data centers prevents focus on key technologies critical to long-term success, like migrating data service to a public cloud infrastructure that'll allow them to focus on big data and machine learning to improve service to customers. Since founding the company has invested heavily in data services infrastructures. However, because of changing market trends, we need to outsource our infrastructure to ensure our long-term success. The model will help us respond to increasing customer demand during peak and reduce costs. Question 135. How should the company structure their GCP domain and projects to follow a least privilege model and separate roles for production and development? Answer. Create a single G Suite account to manage users with one project for the development, testing, stage environments, and one project for the production environment. This model separates duties clearly between environments, allowing the principle of least privilege. Developers and testers are limited to non-production resources, reducing the risk of errors or unauthorized access in production. Question 136. What are 3 potential bottlenecks slowing down the company's cloud migration throughput? Answer. A single VPN tunnel limiting bandwidth, using a Google Cloud storage tier not suited for large transfer tasks, and inefficient copy commands over long distances. Migration throughput can be constrained by VPN bandwidth. Incorrect storage tier selection, like archival or standard, can also be a problem, and tools not optimized for network conditions, all of which slow down data transfer. Question 137. After migration, a cloud database stops accepting SSH but still handles requests. What 3 troubleshooting steps should be taken? Answer. Take a snapshot and mount it to a new VM to inspect. Check the inbound firewall rules to confirm SSH is allowed. Use the serial console and activate the interactive console to investigate boot or access issues. These actions help you access logs or inspect VM configurations without disrupting service or data, and they target network or system misconfigurations that could block SSH access. Question 138. Which Google database is best for migrating the company's user profile data? Answer, Google Cloud Data Store. Cloud Data Store is a NoSQL, fully managed database ideal for handling document-like user profiles with high availability, scalability, and automatic sharding. Question 139. During migration, how should service accounts be managed for secure access between the on-prem infrastructure and GCP? Answer, provision service account keys for the on-prem infrastructure and use GCP managed keys for compute engine VMs. This setup ensures secure, controlled access from on-prem systems while offloading key management for VMs to Google Cloud, reducing complexity and security risks. Question 140. The company is deployed in Asia. Which metrics should be tracked to evaluate performance and success? Answer, total visits and average latency for users in Asia. These metrics align with business goals, expanding the user base, and technical requirements like decreasing latency. Monitoring these KPIs ensures insights into usage and user experience in the region. Case study 4. This web-based company that helps their users organize and manage their personal wardrobe using a website and mobile application. The company also cultivates an active social network that connects their users with designers and retailers. They monetize their services through advertising, e-commerce, referrals, and a freemium app model. So the company's application has grown from a few servers in the founder's garage to several hundred servers and appliances in a co-located data center. However, the capacity of their infrastructure is now insufficient for the application's rapid growth. Because of this growth and the company's desire to innovate faster, the company is committing to a full migration to a public cloud. So, for the first phase of the migration to the cloud, the company is considering moving their development and test environments. They're also considering building a disaster recovery site because their current infrastructure is at a single location. They're not sure which components of their architecture they can migrate as is and which components they need to change before migrating them. So here's the existing technical environment. Application is served out of a single data center location. The databases are MySQL for user data, inventory, and static data, and Redis for metadata, social graph, and caching. The application servers include Tomcat for Java microservices, Nginx for static content, and Apache Beam for batch processing. The storage appliances include ISCSI for VM hosts, Fiber Channel SAN for MySQL databases, and NAS for image storage, logs, backups. Hadoop, Apache Hadoop, and Spark servers include for data analysis, real-time trending calculations, and MQ servers are here for messaging, social notifications, and events. Miscellaneous servers are also included for Jenkins, monitoring, Bastion hosts, and security scanners. Business requirements. So the business requirements are to build a reliable and reproducible environment with scaled parity of production, and improve security by defining and adhering to a set of security and identity access management. And access management best practices for the cloud. So let's repeat that. Improve security by defining and adhering to a set of security and identity and access management best practices for the cloud. Next would be to improve business agility and the speed of innovation through rapid provisioning of new resources, analyze and optimize architecture for the performance in the cloud, migrate fully to the cloud if all other requirements are met. Technical requirements include being able to evaluate and choose an automation framework for provisioning resources in cloud, supporting failover of the production environment to cloud during an emergency, identifying production services that can migrate to the cloud to save capacity, using managed services wherever possible, encrypting data on the wire and at rest, and supporting multiple VPN connections between the production data center and the cloud environment. So the CEO says that the investors are concerned about the ability to scale and contain costs with the current infrastructure. They're also concerned that a new competitor could use a public cloud to offset their upfront investment and free them to focus on developing better features. CTO says that they've invested heavily in the current infrastructure, but much of the equipment is approaching end of life, and They're consistently waiting weeks for new gear to be racked before they can start new projects. So the traffic patterns are the highest in the mornings and in the weekend evenings. During other times, 80% of the capacity is sitting idle. The CFO says that the capital expenditure is now exceeding quarterly projections. So migrating to the cloud will likely cause an initial increase in spending, but fully expect to transition before the next hardware refresh cycle. So the total cost of ownership, TCO, analysis over the next 5 years puts a cloud strategy between 30 to 50% lower than the current model. Question 141. How should the company's operations team archive database backup files remotely at low cost? Answer. Use a cron script with gsutil to copy files to a cold line storage bucket. gsutil is optimal for transferring files from on-premises. Cold line storage is cost-effective for long-term backups, accessed infrequently, making it ideal for archived tar files. Question 142. What method should be used to recommend cloud machine types for the company's application servers? Answer. Map on-premises cores and RAMs to the nearest equivalent cloud machine types. This approach ensures performance parity and provides a clear starting point for selecting suitable cloud instances based on existing workloads. Question 143. How should the company migrate MySQL to the cloud while minimizing downtime and performance impact? Answer. Set up a MySQL replica in the cloud. Configure asynchronous replication from the on-premises master until cutover. This method maintains near real-time sync with minimal disruption, enabling a smooth transition to the cloud. Question 144. What should dress for when What should the company do if Stackdriver uptime checks aren't detecting their legacy health services as healthy? Answer. Configure legacy web servers to allow requests for the user agent header. Google Stackdriver monitoring -uptime checks. Why? Stackdriver uptime checks use this user agent to probe services, allowing these requests ensure accurate monitoring results. Question 145. What's the best option for storing the company's sales and tax records for 10 plus years at low cost? Answer. Store data in cold line storage and access it with gsutil. Cold line is optimized for long-term and infrequently accessed storage. It's ideal for compliance data like audit records. Question 146. What should the company add to ensure no bugs occur after cloud migration? Answer. Add unit tests and production scale load tests in the cloud staging environment. Unit tests catch component level bugs. Load tests validate cloud performance under real world conditions. Question 147. How should the company manage user image uploads and privacy while ensuring low latency? Answer. Store images in cloud storage and use Cloud Data Store for metadata linked to customer IDs. This approach separates image data from access control metadata, ensuring fast access and proper privacy management. Question 148. How can the company's operations team manage VMs without external SSH access? Answer. Set up a VPN to GCP to allow secure internal access to VMs. A VPN provides secure access without exposing VMs externally, complying with security restrictions while enabling full management. Question 149. What should the company migrate first to quickly gain cloud experience with minimal changes? Answer. Move in-house databases to the cloud and continue serving requests from on-prem applications. Databases are self-contained and easier to migrate, offering immediate benefits while keeping application logic untouched. Question 150. Which Stackdriver features support monitoring, error alerts, and debugging across a distributed cloud system? Answer. Monitoring, trace, debug, and logging. This suite provides observability into performance, scalability, and root cause analysis. Trace and debug complement real-time monitoring for deep insights. Case study 6. This company manufactures heavy equipment for the mining and agricultural industries. About 80% of their business is from mining and 20% from agriculture. They currently have over 500 dealers and service centers in 100 countries. Their mission is to build products that make their customers more productive. So There are about 20 million vehicles in operation that collect 120 fields of data per second. The data is stored locally on the vehicle and can be accessed for analysis when a vehicle is serviced. The data is downloaded via a maintenance port. This same port can be used to adjust operational parameters, allowing the vehicles to be upgraded in the field with new computing modules. Approximately 200,000 vehicles are connected to a cellular network, allowing them to collect data directly. At a rate of 120 fields of data per second with 22 hours of operation per day, the company collects about 9 terabytes per day from these connected vehicles. So, here's the technicals. This company's existing architecture is composed of Linux and Windows-based systems that reside in a single US West Coast-based data center. These systems gzip CSV files from the field and upload via FTP and place the data in their data warehouse. Because the process takes time, aggregated reports are based on data that is 3 weeks old. With this data, the company has been able to preemptively stock replacement parts and reduce unplanned downtime of their vehicles by 60%. However, because the data is stale, some customers are without their vehicles for up to 4 weeks while they wait for replacement parts. So, the business requirements are to decrease unplanned vehicle downtime to less than 1 week, support the dealer network with more data on how their customers use the equipment to better position new products and services, and have the ability to partner with different companies, especially with seed and fertilizer suppliers in the fast-growing agricultural business, to create compelling joint offerings for their customers. So, the technical requirements are to expand beyond a single data center to decrease latency to the American Midwest and the East Coast, create a backup strategy, increase the insecurity of data transfer from equipment to the data center, and improve data in the data warehouse, and use customer and equipment data to anticipate customer needs. So application 1, a data ingest. A custom Python application reads uploaded data files from a single server and writes to the data warehouse. Then compute is a Windows Server 2008 R2 with 16 CPUs, 120 gigabytes of RAM, and 10 terabytes of local HDD service. Application 2 for reporting. An off-the-shelf application that business analysts use to run a daily report to see what equipment needs repair. Only 2 analysts of a team of 10, 5 West Coast, 5 East Coast, can connect to the reporting application at a time. Compute. Off-the-shelf application, licensed tied to a number of physical CPUs. The Windows Server 2008 R2, 16 CPUs, 32 gigabytes of RAM, 500 gigabytes of HDD storage. The data warehouse, a single PostgreSQL server with Red Hat Linux, 64 CPUs, 128 gigabytes of RAM, and 4 6-terabyte HDDs and RAID 0. The executive statement is saying that the competitive advantage has always been in the manufacturing process, with the ability to build better vehicles for lower cost than competitors. However, new products with different approaches are constantly being developed, and they're constantly worried that they lack the skills to undergo the next wave of transformations in the industry. And the goals are to build skills while addressing immediate needs through incremental innovations. Question 159. To comply with GDPR, this company must delete European customers' personal data after 36 months. Data is stored in cloud storage and BigQuery. What should be done? Answer. Create a time-partitioned BigQuery data for European data and set the partition expiration to 36 months. Enable cloud storage cycle management with a delete action and an age condition to 36 months. See, time-partition data tables in BigQuery allow setting a partition expiration, ensuring old data is automatically deleted. In cloud storage, lifecycle policies with the delete action clean up files after 36 months, satisfying GDPR data retention rules. Question 160. This company wants to store 1 year of data in cloud storage while minimizing cost. How should the lifecycle policy be configured? Answer. Create a lifecycle rule to move objects from standard to cold line storage after 30 days, and another rule to delete objects after 365 days. Moving objects to cold line after 30 days reduces storage costs, as cold line is cheaper for infrequent access. Deleting the data after 1 year keeps storage costs minimal. Question 161. How should the company redesign their data warehouse in GCP to meet business and technical goals? Answer. Replace the existing data warehouse with BigQuery and use federated data sources. BigQuery with federated queries allows direct access to data stored externally, like in cloud storage, without requiring ingestion. This setup is scalable, cost-effective, and minimizes operational overhead. Question 162. A new BigQuery-based architecture showing dirty data. How should the company automate daily data cleaning efficiently? Answer. Use Cloud Data Prep, connect it to BigQuery, and schedule a daily job to clean the data. Cloud Data Prep is a purpose-built for data cleaning and transformation tasks. It works seamlessly with BigQuery and can automate cleanup operations on a schedule without heavy custom engineering. Question 163. What architect should the company implement to reduce vehicle downtime using GCP? Answer. Stream data from vehicles into BigQuery using Cloud PubSub and Cloud Dataflow. Then use Cloud Data Studio for analysis and reporting. Streaming data into BigQuery enables near real-time analytics. This helps predict maintenance needs faster, which directly reduces unplanned downtime. Data Studio makes visualizations and reporting easier for business users. Question 164. This company needs to ingest data securely from 200,000 connected vehicles. Which components should be used? Answer. Cloud IoT, Internet of Things Core, with public-private key authentication. Cloud IoT Core is designed for massive scale, securely managing device connections with key-based authentication. It fits the needs for secure, large-scale ingestion from hundreds of thousands of vehicles. Case study 7. This company makes online session-based multiplayer games for mobile platforms. They build all their games using some server-side integration. Historically, they've used cloud providers to lease physical servers. Due to the unexpected popularity of some of their games, they have had problems scaling their global audience, application servers, MySQL databases, and analytics tools. Their current model is to write game statistics to files and send them through an ETL tool that loads into a centralized MySQL database for reporting. So the company is building a new game, which they expect to be very popular. They plan to deploy the game's backend on a Google Compute Engine so they can capture streaming metrics, run intensive analytics, and take advantage of its autoscaling server environment and integrate with a managed NoSQL database. The business requirements are to increase to a global footprint, improve uptime because downtime is a loss of players, increase efficiency of the cloud resources we use, and then reduce latency to all customers. The technical requirements for the game backend platform include dynamically scaling up or down based on game activity, connecting to a transactional database service to manage user profiles and game state, storing games activity in a time series database service for future analysis, and as the game scales, ensure the data is not lost due to processing backlogs, and running a hardened Linux distro. So the requirements for the game analytics platform are to dynamically scale up or down based on game activity, process incoming data on the fly directly from the game servers, process data that arrives late because of slow mobile data networks, allow queries to access at least 10 terabytes of historical data, process files that are regularly uploaded by users' mobile devices. So the executive statement is that the last game did not scale well with the previous cloud provider. This resulted in lower user adoption and affected the game's reputation. Investors want more key performance indicators to evaluate the speed and stability of the game, as well as metrics that provide deeper insight into usage patterns that they can adopt to make the game better targeted to users. Also, the current tech stack cannot provide the scale they need. So they want to replace MySQL and move to an environment that provides autoscaling, low latency load balancing, and frees up from managing physical servers. Question 165. The company wants to migrate their analytics and statistic reporting model to better meet technical requirements of Google Cloud Platform. Which 2 steps should be part of the migration plan? Answer. Evaluate the impact of migrating the current batch ETL code to Cloud Dataflow. Write a schema migration plan to denormalize data for better performance in BigQuery. Cloud Dataflow enables scalable real-time for batch data processing, critical for processing live game data. Denormalizing data enhances BigQuery query performance by reducing expensive joins, making the system faster and more efficient. Question 166. How should the companies architect their compute workloads to meet their business and technical requirements? Answer. Create a global load balancer with managed instance groups and auto-scaling policies using preemptible compute engine instances. A global load balancer with auto-scaling managed instance groups ensures high availability and scalability worldwide. Preemptible instances offer significant costs for dynamic burstable workloads like gaming backends. Question 167. The company wants to use wants to design a future-ready solution that benefits from ongoing cloud improvements. Which two actions should they take? Answer. Set up a CI/CD pipeline using Jenkins and Spinnaker to automate canary deployments and improve development velocity. Implement a weekly rolling maintenance process for Linux virtual machines to apply updates and minimize vulnerabilities. Implementing a CI/CD pipeline accelerates deployment and testing cycles, whilst weekly rolling maintenance keeps systems secure and highly available without major downtime. Question 168. How should the company test their analytics platform resilience to changes in mobile network latency? Answer. Add the ability to introduce a random amount of delay before processing analytics files uploaded from mobile devices. Introducing random delay simulates real-world latency conditions, helping the company ensure the system remains stable even when the mobile networks are slow. Question 169. How should the company design the database workloads to meet their business and technical needs? Answer. Use Cloud Bigtable for time series data, Cloud Spanner for transactional data, and BigQuery for historical data queries. Cloud Bigtable efficiently handles real-time time series data. Cloud Spanner provides strong consistency and scaling for transactional workloads, and BigQuery excels at analyzing large historical data sets. Question 170. Which managed storage option meets the company's need for storing game activity as time series data? Cloud Bigtable. Cloud Bigtable is a purpose-built for high-volume time series workloads, making it ideal for storing real-time game activity telemetry data. Question 171. How should the company design the back-end platform for the REST API according to Google best practices? Answer. Create an instance template for the backend. Deploy it on multi-zone managed instance groups for every region and use an L4 load balancer. Deploying across multi-zone managed instance groups ensures high availability within the regions. An L4 load balancer efficiently distributes TCP traffic, ideal for REST API communication. And that is the end. So over these past few days, we've reviewed 9 chapters of Google Cloud resources and sample test questions so that you should be able to tackle these tests in the Google Cloud platform and be able to solve problems for your employer. Wish you the best. Go build something.